So, how does a mission to Mars, we're talking hundreds of millions of dollars, years of work by some of the smartest people on the planet, just disappear? It's an absolutely wild story of sky-high hopes and, well, a catastrophic failure. And it all came down to one tiny, overlooked detail in the data. Okay, so picture this. It's September 1999, deep inside NASA's Mission Control. The Mars Climate Orbiter is just minutes away from firing its engines to enter orbit around Mars. I mean, this is the nail-biting climax of a journey that's taken months. The whole team is just holding their breath, waiting for that signal, the one that says, "I'm here, I made it." But that signal, it never arrives. The orbiter goes behind Mars, exactly like it was supposed to. But on the other side, when it should have reappeared, there's just nothing. Not a blip, no data. Just complete, deafening silence from 140 million miles away. A mission that took years to build was just gone. And the stakes here were just immense. This wasn't just a scientific bummer. This was a $327 million catastrophe. All that precious data it was supposed to gather about the Martian climate, all those years of work, it all just vanished, probably burning up in the Martian atmosphere. So, of course, the big question was, what on earth happened? The investigation was frantic. Engineers were scrambling, looking at everything. Was it an engine failure? Did some critical piece of software crash? The real answer, when they finally found it, was something so much simpler, and honestly, so much more shocking. So let's get into it. The simple, almost silly error that brought this whole incredibly complex mission to its knees. This is where the story gets really, really interesting. And here it is. The culprit was a unit mismatch. The entire mission failed because of this right here. One team was using imperial units, pounds of force, while the other team was using metric, newtons. It's like they were speaking two totally different mathematical languages, and the program that was supposed to translate between them, well, it just wasn't there. Here's the breakdown. Lockheed Martin, the company that built the orbiter, wrote the software that controlled the thrusters using pounds. But back on the ground, the navigation team at NASA's Jet Propulsion Laboratory was plugging those numbers into their own software, assuming they were in newtons, the metric standard. Because of that, every single course correction was off by a factor of about 4.45. The orbiter was getting pushed way off course, and nobody knew. Now, this is where the database part of our story is so critical. It wasn't just a simple miscommunication between two people. The real weak link in the chain was the system that passed the data from one team to the other. Lockheed's software sped out a number. The database system just grabbed that number and handed it right over to NASA. It never checked, it never validated, it never had a little flag that said, "Hey, by the way, what unit is this in?" It just blindly passed along the wrong information. You might be wondering, how could an error this basic, this fundamental, actually happen at NASA? To get that, we've got to look at the bigger picture of how we used to handle data. This wasn't just one person's bad day. It was a problem that had been brewing in the way we built systems for decades. Think about how things evolved. In the 60s, it was all written down in lab notebooks. Then we got punch cards, then these clunky flat files. By the 90s, we had what we called integrated databases. But here's the kicker. Even as the technology got more powerful, a lot of the old habits stuck around. We just assumed the context was understood. And that led to these huge hidden flaws. People were still manually connecting different software systems. Crucial assumptions, like what units you're using, were just implied. They weren't written into the code. And metadata, the data about your data, it was treated like an optional extra, not a core part of the system. And the most important piece, nothing was automated. There was no automatic check to catch this exact kind of mistake. Well, when you have a failure this big, this public, and this expensive, it forces you to change. The loss of the Mars Climate Orbiter was an incredibly painful lesson, but it completely revolutionized how NASA and really the entire scientific world thinks about data. This whole disaster really put a spotlight on a concept we now call data integrity. And what that means is, it's not enough for a number to just be correct. For data to be worth anything, it has to have context. What is this number measuring? What units is it in? What assumptions are baked in? Without that context, data isn't just useless, it can be incredibly dangerous. So the takeaways were crystal clear. You have to enforce unit consistency from day one. You have to treat metadata as a non-negotiable part of your database. You have to code your assumptions into the system itself so they can't be forgotten. And you absolutely have to automate your checks and balances, because as this mission proved, a tiny little error in your data can literally have planetary consequences. There's a quote from the official investigation that just says it all perfectly. The harsh environment of Mars isn't what killed this mission. What killed it was ambiguity, a simple lack of clarity in the data that doomed the spacecraft before it ever got there.
But the story really doesn't end in failure. The legacy of this massive screw-up is actually a whole set of changes that have made every single mission since then that much safer. In a weird way, this disaster became a blueprint for how to handle data the right way.
So what do they actually do? Well, they built new protocols from the ground up. Databases are now designed with what are called unit-aware schemas, which means the system itself knows the difference between feet and meters. Teams use live dashboards to spot problems as they happen, and they do things called assumption audits to literally sit everyone down in a room and make sure they're all speaking the same language. And this brings us right back to today. The Mars Climate Orbiter was a very public failure, but its root cause, a simple mismatch in assumptions about data, happens all the time in less dramatic ways. In our world, which is totally run on data, from our finances to our healthcare, it makes you wonder, what's the simple unit mismatch that we're all ignoring right now? Next time, we're coming back down to Earth and heading to the factory floor. We're going to dive into what happens when a database migration goes horribly wrong and brings an entire car assembly line to a grinding halt. Thanks for joining me.